binary system, massive stars with magnetic fields, their interaction explained. And is this happening to Earth? This is something recently found by a PhD student. He found two massive stars with magnetic fields, and they're in their binary system. This is the image that we have showing the polarity of the star's surface, magnetic field, north or south, is indicated by red and blue respectively. The yellow lines indicate the magnetic field lines running from the stellar surface. And this is courtesy of Volkmar, Holsworth, Chris Freiberg, and it's an image also by the Royal Astronomical Society of UK. Huge stars that interact with magnetic fields in a binary system. As many as half of all stars, they say, in our galaxy do come in pairs. Half of all the stars. And it's called binary system. It means that they're composed of multiple stars, binary meaning two. Now, there's multiple stars orbiting a common center. And in a new study published in the monthly notices of the Royal Astronomical Society, Matt Schultz, a Canadian PhD student at Queen's University in Ontario, Canada, announces the discovery of a unique stellar object. Two massive stars with magnetic fields within a binary system. The system here is Epsilon Lupi, and it resides in the constellation Lupus, approximately 500 light years from our Earth. As part of the binarity and magnetic interactions in various classes of stars, Dynamics Consortium, led by Dr. Evelyn Alessia of Francis University of Grenoble, Schultz studied the magnetic properties of close binary stars. The BINA-MICS project, understanding the origin of magnetic fields in massive stars through close binary systems, it's well established now that a fraction of the massive star population hosts strong, organized magnetic fields, most likely of fossil origin. The details of the generation and evolution of these fields are still poorly understood. The BINA-MICS project makes it an important step towards understanding of the interplay between binarity and magnetism during the stellar formation and evolution, and in particular the genesis of fossil fields by studying the magnetic properties of closed binary systems. The components of such systems are most likely formed together at the same time and in the same environment, and can therefore help us to disentangle the role of initial conditions on the magnetic properties of the massive stars from other competing effects such as age or rotation. We present here, they say, the main scientific objectives of the BINA-MICS project, as well as preliminary results in the first year of observations from associated ESPADONS and Narval spectropolarimetric surveys. This is what Cornell University states, but let's go back to that's concerning the close binary stars. Going back to the article of the massive binary stars with magnetic fields in the binary system, astronomers have known for many years that Epsilon Lupi, the fourth brightest star in the southern constellation of Lupus, is actually a pair of blue stars, roughly 6,000 times more luminous than our Sun. Each star is a pair. In the pair has a mass of approximately 7 to 8 solar masses, so they're huge. By observing the star system with the Canada-France-Hawaii telescope, CFHT, on Mauna Kea in Hawaii, Schultz was able to discover that both stars in the system have their own magnetic fields. The origin of these fields around massive stars is a mystery Schultz hopes that this discovery will help solve. Schultz comments in a statement, quote, The origin of magnetism among massive stars is something of a mystery, and this discovery may help to shed some light on the question of why any of these stars have magnetic fields. End quote. In cooler stars like the Sun, we know that magnetic fields are generated as a result of strong convection processes in the star's outer layer. Now, I'm going to have the images of some binary systems later on from NASA videos and from the Wikipedia, so you can see how they interact with each other. But let's go on with this. In cooler stars like the Sun, we know magnetic fields are generated as a result of strong convection processes in the star's outer layer. This is not the case with stars like Epsilon Lupi, as hotter, more massive stars lack a similar convection process in the outer stellar envelope. Despite the absence of convection, up to 10% of massive stars in our galaxy have a strong magnetic field. 10%. There are two possible explanations for this, both involving the notion of a fossil magnetic field, which is a field generated sometime during the star's life and locked into the stellar surface. Such a magnetic field could be generated while a star is forming. Another possibility is that when two stars merge to form a binary system, the violent exchange of material could generate a magnetic field. Quote, "This discovery allows us to rule out the binary merger scenario," Schultz said, explaining the data collected indicates the newly discovered magnetic fields are similar in strength, but their magnetic axes are not aligned, meaning the magnetic south pole of one star lines up with the magnetic north pole of the other star. I guess that's why, as we hold two magnets together, that's how they attract each other. The opposite poles attract each other. Going now into this, it says we're not sure yet why yet, but it probably points to something significant about how the stars are interacting with one another, Schultz added. Due to their close proximity, the stellar duo's respective magnetospheres, an area surrounding each star that is influenced by its magnetic field, could be interacting. This interaction could potentially slow down the star's rotation like a giant cosmic brake, ultimately pulling the stars towards each other. Since binary systems are common throughout the galaxy, they are invaluable tools for astronomers. Understanding how magnetic fields are generated around massive stars will provide keen insight into how stars evolve. Now, this is something that was brought up recently by Terrell Blackstar's recent video concerning the black star or brown dwarf star or something that's at the edge of our solar system, and how it aligns with and our other giant planetary giants like Jupiter, how various things in our solar system, especially during planetary alignments, cause earthquakes on Earth, of course. Even the moon causes earthquakes, especially when it's around full moon. And this has been confirmed and explained to us by U.S. Geological Survey, that not only does it have an effect on the tides of the Earth, the water, but also the earth tides, meaning the tectonic plates of Earth. Now we'll go into what a binary star looks like. Wikipedia, binary star, a star system consisting of two stars orbiting around their common barycenter. Systems of two or more stars called multiple star systems. These systems, especially when more distant, often appear to the unaided eye as a single point of light and are revealed by multiple by other means. Research over the last 2 centuries suggests that half or more of visible stars are part of multiple star systems. So that's 50% chance that Earth does have a binary star. The term double star is often used synonymously with binary star, but double star can also mean optical double star. So let's look at this artist's impression of the evolution of hot or mass binary star. Let's play the video. ESO, that's the European Space Organization. There we go. Star 1, solar masses, temperature 35,000 degrees. Star 2, mass about 15 solar masses, temperature 30, a little bit cooler. I don't know why it's in Russian underneath, but anyway. Look at that. What is that? Why is it in Russian? Anyway. This artist's impression of the evolution of a high-mass binary star and why is it, oh, it's somehow interacting with each other. The big one is losing mass and star 2 is gaining mass. Can you see that? Look at that. Star 2 is now bigger. Look at that. Primary star becomes smaller and hotter, loses mass in the stellar wind. What is that? Primary star explodes as a supernova creates a neutron star. Amazing. And the binary is disrupted. Star 1 mass. Star 2 mass. What happens? The second star explodes as a supernova having a neutron star, leaving a neutron star. Amazing. That's in millions of years. Amazing. Right. Great. And this is a picture of one Hubble image of Sirius binary system in which the Sirius B can be clearly distinguished in the lower left, right there. Binary systems are very important in astrophysics because calculations of their orbit show the masses of their component stars to be directly determined, which in turn allows other stellar parameters such as the radius and intensity to be indirectly estimated, and it also determines the empirical mass-luminosity relationship from which the mass of single stars can be estimated. Amazing. And I think there's some more down here. System with 2 stars. Edge on disk of gas and dust present around the binary system. There we go. Oh, there we go. How's that? This animation was assembled from 55 images of the Chara interferometer in the near-infrared H band, sorted according to orbital phase. Okay. Eclipsing binaries. The video shows artist's impression of an eclipsing binary star system. As the 2 stars orbit each other, they pass in front of one another and their combined brightness, seen from a distance, decreases. Let's see that as well. ESO again, European Space Organization. There we go. Brightness over time. Okay. They're both. They seem just as bright to me anyway, but anyway. Dips, what dips? All right. I really can't see any difference. Maybe I'm just... All right. Interesting. So half the stars in our galaxy are binary stars. All right? So we have a 50% chance that ours is as well. We're learning things concerning astronomy all the time. Cataclysmic variable system, one eats up the other. Okay. Turning into neutron stars. Artist's impression of binary star system. All right. Mass transfer and accretion. We saw that the first one on top. Center of mass animations. 2 bodies of similar mass orbiting around a common center of mass, the barycenter. 2 bodies with a difference in mass orbiting around a common barycenter like the Charon-Pluto system. All right, that's a bigger body, that's the, okay. One is inside, one is outside. 2 bodies with a major difference in mass orbiting around a common barycenter, similar to the Earth-Moon system. All right. 2 bodies with an extreme difference in mass orbiting around common barycenter, similar to the Sun-Earth system. Yes. 2 bodies with similar masses orbiting in an eclipse around a common barycenter. Look at that. Yeah, okay. Amazing. Artist's impression of sight from a hypothetical moon of planet whatever, which orbits the triple star system. All right. And the third closest star system containing 2 brown dwarfs. Multiple star examples. So, Terrell Black star, the massive binary star system with the magnetic fields is what gives us our jolts, our electromagnetic jolts, and it does have an influence on the Earth changes and activity in our magma plumes, tectonic plates, and of course our earthquakes and volcanic eruptions. I'll leave links below for you for this. Thank you. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.